Hello everyone, this is Dr. E, and for today we're going to be working on quadratic inequalities, but this time we're going to be solving word problem involving quadratic inequalities. From our last lesson, we've learned that there are 3 steps or procedures that you need to work on in solving quadratic inequalities. The first one is to find the critical numbers by factoring or using the quadratic formula or completing the square. And then the next one would be working on the sign chart to check whether your statement is true or false in the intervals that we have worked on from the critical points that we have found from step 1. And the last step is testing our critical numbers and the intervals by plugging in the values of x in those partitions. And that's what we're going to be working on today, but this time it's going to be in word problem form, and it's going to be more challenging compared to solving quadratic inequalities right away, because the challenge when we're working with quadratic inequalities in word problem is we are tasked to come up with our quadratic inequalities and making sure that it's correct based on the problem that we are working on. Similar to problem number 1, wherein an object is launched from the ground level directly upward at the rate of 144 feet per second. Now, the equation of the object's height is given by the function y is equal to negative 16x squared plus 144x, which is a quadratic equation because when we throw something upwards, it's bound to go down and it creates a parabolic graph. That's why it's considered to be a quadratic equation. That's why we have a formula that is in quadratic form, because that is the behavior of the object being launched from the ground, and we have negative 16x squared plus 144x for that. And we're going to be solving for the values of x when the object is at or above a height of 288 feet. Forgive my spellings because it's supposed to be H-E-I-G-H-T, but for today, we're going to be working on solving quadratic inequalities, and we have the quadratic equations. We just need to form the quadratic inequalities, and we will do that by answering the problem in our word problem, which is finding the values of x where the object is at or above a height of 288 feet. And the equation you are seeing is the equation of the object height. So all we need to do is to use that and form our inequality. And the clue is already there, at or above, which means our inequality would look something similar to this one. So we have negative 16x squared plus 144x greater than or equal to 288. So let's work on that inequality by solving the inequality. So let's write it down. So from our word problem, we have negative 16x squared plus 144x greater than or equal to 288. So the first thing that we need to do is to formulate our quadratic inequality that should be greater than or equal to 0, which means our right-hand side should equal to 0. And to do that, we're going to subtract 288 on both sides, leaving us with a new quadratic inequality, which is negative 16x squared plus 144x minus 288 greater than or equal to 0. And by doing so, we'll be able to now solve for the inequality by factoring, completing the square, or quadratic formula. But in this particular case, we can factor it out because we know that we can take out the negative 16 here, and we are left with x squared equal to negative 9x plus 18. So I already have this prepared a while ago. So I already know that if I take out negative 16, we will have a quadratic inequality, which is x squared minus 9x plus 18 greater than or equal to 0. And what we need to do is to factor this out. And we will have our critical numbers. And we know that the factor of 18 that will give us negative 9 when we add them up will be negative 16 x minus 6 times x plus 3 greater than or equal to 0, because 3 times negative 6 is positive, not positive 18, so it should be both negative. Let's check it again. Negative 3 times negative 6 is positive 18, and negative 6 plus negative 3 is negative 9. So now we have our critical number. So our critical number will give us the zeros of our factors, which will be at x equal to 6 and x is equal to 3. So now that we have our critical number, which is the first step in solving quadratic inequality, we can now work on our sign chart or number line, and it's going to be between 6 and 3. So between 6 and 3, so 3 comes first before 6, and we know that 0 is somewhere here. So now we have 3 partition. Anything that is less than 3, anything that is in between 3 and 6, and anything to the right of 6. So all we need to do is to use our sign chart and see when our inequality is going to be true from this inequality. So that's what we're going to be working on. So let's go back to our presentation and work on our inequalities. So first, we need to find the critical points or the critical numbers by factoring out our quadratic, which is negative 16x squared plus 144x minus 288. And now that we have found our critical numbers, which is at 6 and 3, we're able to produce our number line, which we will use to check our sign chart to see which partition will give us a true statement. So all we need to do is to have, we can either use our inequality, quadratic inequality in its standard form, or we can also use our inequality in factored form. So I always use the factored form because it's a lot easier to manipulate. So for anything to the left of 3, I chose 0 as my value of x and see if it's going to be a true statement, and the answer or our number will give us a number greater than or equal to 0. So by doing so, we have negative 288, and that negative 288 is it greater than or equal to 0, or is it bigger than 0? And we know that it's false because a negative number will always be less than 0. So for our first interval, which is anything to the left of 3 or less than 3, it's going to be a no solution for this particular problem. And now in between 3 and 6, I will use 4 in this particular problem. So in between 3 and 6, it could be 4, or it could be 5, or if you want, you can use 3.1 or 5.9, as long as it's not 3 and 6. And in this case, our answer is a 32 when x is equal to 4. So this is a true statement because we know that 32 is greater than 0. So now that we know that our solution is true in between 3 and 6, including 3 and 6, and for the last partition, let's see if this is true for x is equal to 7, which is a number greater than 6, and we know that it's negative 64. Now the question is negative 64 greater than or equal to 0? And we know that this is false. That's why we know that our answer is only going to be true in between 3 and 6. That means, to answer the question, what values of x is the object at or above a height of 288 feet, the answer is going to be in between 3 and 6 seconds based on this inequality that we have just formulated. So this is our first word problem involving quadratic inequality. The next one that we're going to be working on is a rectangle problem, wherein a rectangle has a length of 10 meters, more than twice the width of that particular rectangle. Now, what we need to do is to find all the possible widths that result in the area of the rectangle that should not exceed 100 squared meters. So the first thing that we need to focus on is our first statement. And on our first statement, it says there that the rectangle has a length of 10 meters more than twice the width. So that means the length is already defined, and the value of the length in this word problem is 10 meters more than twice the width, which is translated in this algebraic form of our equation. So now we can simplify this as L is equal to 10 plus 2W. And that was our first statement. And in our second statement, we're seeing that we're working with the area of a rectangle. And we know that the area of the rectangle or any quadrilateral is given by length times width. So now that we have our length times width and we're working with an algebra problem, we know that we can modify our formula from having a two-variable formula, which is L and W. We can convert this into a single variable by applying our value of the length. Because length is 10 plus 2W, if we replace L by 10 plus 2W, we'll be able to simplify our formula in such a way that our area is going to equal to an expression that has one variable, which is the width or W. So by distributing W to 10 and 2W, area is now 10W plus 2W squared. And by doing so, we're not done yet because we're working on quadratic inequalities that is not exceeding 100 squared meters. We're going to put this in our equation because we know that the area of the rectangle should not exceed 100 square meters. If we're going to translate it in an algebraic form, it will be equal to A less than 100 squared meters. So now that we have our inequality and we also have the value of the area from our formula that we derived based on the word problem, we can replace A by 10W plus 2W squared. So our inequality is now going to look something like this. 10W plus 2W squared less than 100, which is the algebraic translation of our word problem. And now that we have our sort of quadratic inequality, we are now ready to work on the inequality using the 3 steps that we have done or we're able to practice from our previous lesson. So what we're going to do is just manipulate our inequality. So this time, how are we going to manipulate it? So let's use a little bit of algebra from that inequality. So by doing so, from the inequality that we have 10W plus 2W squared less than 100. We're going to get rid of 100 on the right-hand side so that it will equal to 0. And to do that, we will subtract 100 on both sides. So we'll have 10W plus 2W squared minus 100 less than 100. So now that we have, not less than 100, less than 0. So now that we have our inequality with 0 on our right-hand side, notice that this inequality is not in standard form. So let's change it into the standard form wherein the quadratic term is on the first term plus 10W minus 100 less than 0. And by doing so, we'll be able to solve our inequality by 1, finding the critical number, 2, setting up our sign chart, and 3, checking where our inequality is true in those intervals. So to do that, let's find the critical number by GCF. We know that if we took 2 outside, we are left with W squared plus 10 divided by 2 is 5W minus half of 100 is 50. Less than 0, and this is what we're going to factor out. So we'll be able to find the critical number of our quadratic expression right here. And we know that the factors of negative 50 that will give us positive 5 when we add them up is going to be positive 10 and negative 5. So 2W plus 10W minus 5, because 10 times negative 5 is negative 50, and 10 minus 5 is positive 5. So now we have our inequality, and now we have our critical points, which will be at w equals negative 10 and w equals positive 5. So these will be our critical number, which we're going to be using in our sign chart. So in the sign chart that we have, we'll have three partitions. It's going to be anything to the left of 10, anything in between 10 and positive 5, and anything to the right of 5. So this will be our sign chart, and it is illustrated by this partition. And we know that visual is important in mathematics, so that we'll be able to visualize our sign chart a little bit better. And what we need to do is just to plug in our values for anything that is less than negative 10. So let's set w is equal to negative 11. Anything in between negative 10 and 5, and we know that 0 is in between them, so let's set it to 0. And for the third partition, anything that is bigger than 5, and let's set it to 6, and see to which statement it's going to be true by plugging in our equation. It could either be this equation, we can use this if you want, or we can use the factored form, which is 2 times w plus 10 and w minus 5 greater than 0. And I often use the factored form as opposed to the standard form because it's a lot easier to manipulate values like so in this particular form. So what I'm going to do is answer it from our presentation because I already made it right here. So we have w is equal to negative 10 and w is equal to 5 using the sign chart. We're going to test whether our statement is going to be true for all three partitions or just for some of them. So to be able to do that, we'll start with w equals negative 11, so anything to the left of negative 10. So by doing so, we're able to produce 32, and we know that 32 is not less than 0 because it's a positive number, so this statement is false, which means no solutions will be included anything that is less than negative 10. And in the middle, we have anything in between negative 10 and 5. I chose 0 because it's easier. You can choose negative 9 or positive 4. And we know that the statement will still be consistent even if we use w is equal to 0. And we know that it will be negative 100. And we know that a negative number is less than 0. So this statement is true. So any number in between negative 10 and 5 will give you a true statement, so that will be our interval that will give us a true statement for this partition. And let's see if it's also true or maybe false for the last partition by choosing w is equal to anything higher than 5. I chose 6 because it's the smallest number that we could use that is greater than 5. So by plugging it into our factored form of the inequality, we got 32, and we know that 32 is not less than 0 because it's a positive number. So we know that the statement will only be true for the middle interval, which is anything in between negative 10 and 5. But take note that we're looking for the width of our rectangle, and we cannot have a negative width because a negative width does not exist, because if we don't have a width or a representation of the width of a rectangle, the rectangle will not exist. So that means in this inequality, we can get rid of any number that is negative. So our inequality is just anything that is less than 5. So that is the value of our width that will satisfy the condition of our rectangle, which is an area of a rectangle that will not exceed 100 squared meters, because anything that is equal to or greater than 5, your area, when you compute for it, will give you a number or an area that is over 100 squared meters. So this is how we answer the second part of our word problem involving quadratic inequalities. So just remember that when we are working with inequality, There are 3 steps that you are going to be working on. 1, finding the critical number by solving the quadratic. And 2, using the sign chart and setting it up. And 3, making sure that you are using your substitution correctly to verify if the statement is true on those intervals. The challenge in working out with word problem is constructing your correct inequality or quadratic inequality, as opposed from our previous lesson wherein our quadratic inequality is already in place. All we need to do is to do step 1, 2, and 3. But in working with word problem, we need to use our critical thinking skill and analytical thinking skill to be able to come up with the correct inequality that will help us solve our word problem. This is Dr. E, and see you again next time. Bye!